Okay, guys, so we are going to talk about the centroid in chapter 6.3. Okay, so the centroid is this point here. Point P is the centroid. Okay. All right, and it is created by medians. What is a median? Okay. Medians are, and we're going to actually take this place where we're going to write altitude. We're going to write the word median. A median, it is a segment, a segment that connects the midpoint of a side to the opposite vertex. And when all of the medians come together, okay, they create the centroid, okay? And the fun fact about the centroid is that it cuts each median by 2/3, okay? So the short part is 1/3 of the line, the long part is 2/3 of the line. So AP, this here, is equal to 2/3 of the total AE. Okay, and we're just going to hop right into that because that can be somewhat confusing. Okay, so keeping this in mind, okay, they're telling point P is the centroid of triangle LMN. Okay, they want us to find PN, okay, and QP in each triangle. So if QN, that's this whole length here, if that whole thing is 33, okay, then if QN is equal to 33, okay, QN, the total is, I'm sorry, I didn't mean to write that. Okay, that long part PN is equal to 2/3 of the total QN. So plugging in what we know, PN is equal to 2/3 of 33. To solve for QN, you have to multiply, or PN, I'm sorry, 2/3 times that 33 over 1. 2 times 33 is 66. 3 times 1 is 3. And 66 divided by 3 makes PN 22. Moving on to number 2. Okay. We're told that QN is 45. Okay. So again, I'm going to try to find PN. So PN is equal to 2/3. Notice PN is the long part. PN is equal to 2/3 of 45 of QN. So PN is equal to 2 times 45, which is 90, divided by 3. PN in this case is equal to 30 units. Now I just noticed that in number 1, I forgot to find QP. So I'm going to finish up number 2 and then I'll go back to number 1. QP is whatever's left of QN after we subtract PN. 45 minus 30 makes QP equal to 15. So we have PN is equal to 30, QP is equal to 15, and the two of them together make QN 45. Going back to number 1, to find QP, again, you would take your original length for QN, subtract PN, and you'll find QP to be equal to 11. Sorry, I forgot to do that, guys. Okay, in number 3, QN is equal to 39. So, PN which is the long part, is equal to 2/3 of QN, which is 39. PN, 2 times 39, okay, is going to bring us to 78 divided by 3. So PN becomes 26. Okay, now we find QP. We take QN, which is 39, subtract PN, 26, and we get QP to be equal to 13. Okay, now something you should be noticing while we go through these is that the short side is always half of the long side. Okay, half of 22 is 11, half of 30 is 15, half of 26 is 13. Okay, think about it, it kind of makes sense because PN is 2/3 and QP is 1/3, that's half of 2/3. Okay, so that should always make sense. All right, so point D in this case is the centroid of triangle ABC. All right, so they want us to find CD and CE. Now in this case, they're telling us that DE is 7. That's that short part there. So if the short part is 7, and if we look up here, okay, the short part was always half of the long part. So if the short part's 7, the long part has to be 14, right? DC has to be equal to 2 times 7, which is 14. And then if we want to find CE, we can add the two parts, 7 and 14, to get CE equal to 21. So we have DC is equal to 14, CE is equal to 21. Okay, you do different things depending on what you're given. Again, we are given the short part, DE is 12. Okay, so to find DC, we have to multiply 12 times 2. So DC is equal to 24. In order to find CE, we must add the two parts together. And when we add them together, we end up with 36 units for the total median. Okay? Now, find the coordinates of the centroid of the triangle with the given vertices. Number 6. Okay? Our first part of the plan is to graph our triangle. So we only go up to -1, but we need to get up to positive. Okay, so my x-axis is going to be in the middle. My y-axis, however, is going to be somewhere around here. Okay, so I'm going to graph my triangle using the blue marker. I jumped around. I graphed point A and point C, and now I need to graph point B. Positive 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I have my triangle A, B, and C. Now, keep in mind the centroid is created by using medians. And median is connecting one midpoint to the opposite vertex. So I'm going to solve for the median in this green color. Okay, so first I'm going to find the median of AC. So AC is 1, 2, 3, 4, 5, 6 units long. Half of 6 is 3, and I want to connect that to the opposite vertex. Okay, so that's my first median already drawn. Now my next median is going to be a little more difficult because I'm going to have to find the midpoint oops, let me make this a little smaller. The midpoint of A, B. Okay, and midpoint is x1, x1, which is -2, plus x2, which is 1, divided by 2, and y1 plus y2 over 2. Okay, when we solve for the median, -2 plus 1 is -1 over 2 is -1/2. Okay, -1 plus 8 is going to be 7 divided by 2 is going to be 3 1/2. Okay, so I'm going to make a point for my median at -1/2, +1, 2, 3 1/2. So that's going to be about right here. That's my median of AB, and I'm going to connect it, my midpoint of AB, and connect it to vertex C to create the median. Okay, now at this point, you don't have to find another midpoint because the last median is going to intersect right here just like the other two did, okay, at the centroid, which the centroid is at +1, +2. Okay? Oh, you know what? I don't like that. I'll write my final answer as centroid 1, 2. Okay? So, in essence, when you're creating a centroid, you find your midpoints of your sides, connect them to the opposite vertex. Okay? Number 7. All right, we are going to just split the graph in half, both ways. Okay, and then we're going to graph again in blue. So, -1, 2, 3, 4, 5, +4 is here. -1, +4 is here. -3, -2 is here. So this is D, E, F. Okay, so we have our triangle DEF. Okay, now the midpoint of DF is fairly easy to spot. It's 4 units long, so the midpoint is right there. Okay, and I'm going to connect that midpoint to the opposite vertex, okay, to create one median. So now all I have to do is find the next median. So I'm going to use DE. I'm going to find the midpoint of DE. And again, that is x1 plus x2 over 2. So that's -5 plus -3 over 2. And that's y1 plus y2 over 2. So 4 plus -2 divided by 2. All right. When we solve for this, we get -8 divided by 2, which is going to give us -4. And then we have 4 plus -2, which is 2 divided by 2, which is 1. So we're going to have a midpoint of DE at -4, +1, which is right about here. We take that midpoint and we connect it to the opposite vertex. And we can already see our centroid forming right here with a centroid at -3, +2. So our final answer is our centroid is at -3, +2. All right, on to our last problem. If you're feeling comfortable or you want to try this by yourself, definitely feel free to do that. Pause the video and then you can check your answer after. So I'm going to draw my X and Y axis. Here's my Y axis. Here's my X axis. And by looking at my numbers, I really should be going up by 2s. So that's what I'm going to do. 2, 4, 6, 8, positive 2, 4, 6, 7 is J. 20, so this is 8, 10, 12, 14, 16, 18, 20. 2, 4, 5 is here. This is K. This is J. And then L is at positive 8, positive 3, which is right here. So I have my triangle J, K, L. Okay? So I have triangle JKL. All right, I have to find the midpoint of JL because that's pretty easy. So JL is 1, 2, 3, 4 units long. Okay, so I can cut it in half at that midpoint right there and connect that midpoint to the opposite vertex to create my first median. Then I can find the midpoint of JK. Okay, the midpoint of JK is going to be x1 plus x2, 2, and that's going to be 8 plus 20 divided by 2. Okay, and then it's going to be y1 plus y2 over 2, so 7 plus 5 divided by 2. When I evaluate this, I end up with 28 over 2, which is 14. Okay, and 7 plus 5 is 12 divided by 2, which would be 6. So I get a midpoint of JK at positive 2, 4, 6, 8, 10, 12, positive 14, positive 2, 4, 6, which is right about here. I connect it to my opposite vertex to create a median. Okay, and I see my centroid forming. My centroid is right here. And that's at 8, 10, 12. That's at positive 12, my centroid is at positive 12, positive 2, 4, 5. Okay, so I have a centroid at 12, 5. Okay, so that is all you need to know about centroids. Quickly, if you could grab an extra piece of paper, I just want to create one small chart for you guys to maybe clarify a few things. Okay, so our points of concurrency that we've gone over are the circumcenter, incenter, and centroid. Okay, now they're each created by something different. Okay, the circumcenter is created by perpendicular bisectors. The incenter is created by angle bisectors. And the centroid is created by medians. Remember, a median connects the midpoint of one side to the opposite vertex. Okay? And a small fun fact about each one, okay, is that, fun facts. Okay? The circumcenter is equidistant from the vertices. Okay, the incenter is equidistant from the sides. Okay, and the last part, the centroid, cuts the medians into one part that's 2/3 and one part that's 1/3. Okay, so these are our 3 points of concurrency, how they're created, and the fun fact that is most important to each one. I'll see you guys again for 6.4.